next topics under this chapter is standard deviation. So in this topic, basically what we are going to do is, as I was talking about in the beginning of this particular topic, is that you will find how far each data is deviated from the center of the data. So this is one of the method under the dispersion, where you will be easily find out from the center point, from the mean, how far all the other data are deviated. Okay, so that is a concept behind the standard deviation, and it's very useful in almost all the methods of the statistic from here onwards where we study. Okay, so standard deviation generally we denote with sigma. It's called sigma. Remember, sigma. Okay, the standard deviation generally we denote with sigma. Now let's talk about the formula. If I'm talking about ungrouped data, your standard deviation, that is sigma, is nothing but square root of summation x minus x bar whole square divided by n, or this formula only can be written as summation x square by n minus summation n x by n the whole square. Either you can use this or you can use this particular formula. Both are same. You will get the same result or same answer. No changes at all. In textbook they have also given the shortcut formulas, so I would suggest please don't go by the shortcut formulas, because you will have a lot of formulas to remember. So just remember one formula, that will be more than sufficient. Right? Okay. If I'm talking about group data, both discrete and continuous, you will have only one formula, that is same formula, only frequency you will have to multiply. So x minus x bar the whole square divided by capital N, or if you are writing in this format, what will happen is summation fx square by capital N minus summation fx by n the whole square. Okay, so this is the formula where here you have to find out the mean. You know mean formula very well, that is summation x by n, and here summation fx by n. If you're using this type of formula, you don't have to find the mean separately. So this is the formula that we are going to use to find the standard deviation. Now there are a few things that I would like to discuss here. That is, one is properties of standard deviation. So let me just write here properties of standard deviation. So first property will be, it is always greater than 0. So no matter what, the standard deviation value will always be the 0. The standard deviation value will always be the 0. The second property, what it says is, if you find this x minus x bar whole square and if you sum, your value will be least. X summation x minus x square is nothing but the square of the deviation. The square of the deviation from the mean is always least. The square of the deviation from the mean is always least. And third property is combined standard deviation. Combined standard deviation. You remember in mean we had combined mean, where the two separate means are given and you have to combine and tell that. Similarly, here also we have a combined standard deviation. So combined standard deviation I will denote with sigma c, which is nothing but n1, because two population definitely they will give you sigma 1 square plus d1 square plus n2 sigma 2 square plus d2 square divided by n1 plus n2. Now here your sigma 1 and sigma 2 are standard deviation of A and B, both two population. n1 and n2 is nothing but sample size. d1 and d2, basically what happens, so d1 is x1 bar minus xc bar, and d2 is nothing but x2 bar minus xc bar. So mean for population A, mean for population B will be given to you, that you have to subtract with xc bar. Now what is the xc bar? Is the combined mean. So how do we find the combined mean? That is xc bar is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. So we have done already this particular thing under the mean thing, right? So this is how the combined standard deviation will be found. So this is one of the 5 marker. Most of the time they will ask you from the combined standard deviation, right? So you can pause the video and you can note down this. Before we move on to this, I wish to talk about the coefficient of variation. Coefficient of variation. Now what is this coefficient of variation? Remember, absolute measure, relative measure. So when it comes to relative measure of standard deviation, it's nothing but coefficient of variation, which is also known as CV, and it is denoted with sigma by x bar into 100. Sigma is nothing but standard deviation, x bar is nothing but mean into 100. So this is how you will be denoting the coefficient of variation, and this topic is very, very important because your 10 marker question will arrive from this particular topic, right? So pause the video, make a note of it. We'll see the problem one by one from each topic.